Hello viewers, this is Mitul here. In this module, I'll be covering about 3.2 approximate numerics, which will cover up the data types called real and the float. Let's get started. So this is like an approximate numerics which will contain the real and the float data type related information I'll be giving you. So first of all, like what is approximate numbers? Like in a simple language, if we want to say, then it's the number which is not an exact number. It means like not an exact number which is like an approximate number. Means like the whole or the whole number, exact number or the whole number. Then the syntax of this is like real in bracket and for the float the same syntax remains in the bracket n. Now what is n here? Like is this a size of a data type or what? But no, this is not the size. Instead it is the number of bits that are used to store the mantissa value of the float number in a scientific notation. Now what is the bit specification, or what is the precision, what is the byte size for real data type? So for real data type, the bit size precision, the bit size specification is from 1 to 24. Okay, and the precision value, which is like the total part, like I mean from the number, if you say like the precision value, you understand, right? What is the integer part of the number as well as the number after the decimal point. Both of them are covered up under the precision. That is what it should be there for 7 digits. And what will be the size for the real data type will be 4 byte size. Now 4 byte size when we say means what? 32 bit. How come 32 bit will be there? 1 byte is equal to 8 bit. So if you multiply 4 byte into 8, equivalent to 32 bit, right? For that reason, this is 4 byte size. Now what is the default value for this n as like the mantissa value? So what is the value in bit? That is the default value 24 for the real data type. Now what this 24 bit would contain? So out of this 24 bit, the 1 bit, the very first bit will be used for the signing purpose, meaning for the plus or minus, right? The positive or the negative number. And then the 23 bit out of that 24 will be used for the mantissa value. Okay, meaning like the floating number, scientific notation value. Then what this 32-bit binary representation is. So at a whole, like the 32-bit for the real is what the representation I am telling you here. So the 1 bit, the first bit will be used for the sign, meaning like the plus or minus. Then the subsequent, and I mean after that, like there will be 8 bit which will be used for the exponential value, the exponent character, right? That will be occupying 8 bit, meaning 1 byte. Okay, then 23 bit, which we just saw, right? Like 1 bit of sign and 23 bit of mantissa, the same thing is here. So it is a calculated from the remaining value. Okay, now all of this is like a binary representation if you want to understand in detail. Then the second data type we want to understand is float. Now float starts from 25th till 53 in bits. Okay, so float can occupy 53 bits in a data type. So you can understand fairly, like this is less than the float number of float data type. So it will have the precision value more than real value, right? So real has the precision value as 7 digits, whereas float has 15 digits. What is the size? Double to the real size. The real has the 4 byte size. Here it has a 8 byte size. And what is 8 byte size? 8 byte size again, it is 4 byte is equal to 32 bit and 8 byte is equal to 64 bit. Same way. Then the default value of the n bits value, right? So what will be that value? It will be 53. The maximum limit of the float is 53. That is what is the default size for that. So you basically, when you declare this, declare a variable of float type, then you don't need to specify any of the parameters within. By default, it will fetch 53 bit within that. Okay. So out of which, like, the first bit will be used for the signing purpose, like plus or minus, and then the rest 52 bit will be used for the mantissa value, meaning like the floating number scientific notation. Now 64-bit binary representation of the same is, the first bit will be used for the signing purpose, 11 subsequent bit will be used for exponent value, and then the 52 bit will be used for the mantissa value, like that. Now let us just see the variables in the action. We are declaring here 3 variables of the same data type called real, okay, 1, 2 and 3, and we are going to do what? The first type of check that we are going to make on the real data type is to make sure how the real data type is like storing the values, or whatever value that you assign to this variable, how it is storing it and how it is returning it, right? So let us just understand from this criteria. Digits before decimal point is less than 7 digit. Okay, now if, because the real has a limit of 7 digits, right? So that we are checking here, like digits before decimal point is less than 7 digit only. Okay, and 8th digit from a number is greater than 5, then the 7th digit is rounded to a higher number, otherwise keep it as it, or kept as is. Okay, now say like the variable value, we are assigning this value 123412.54, then we are setting for the real 2, we are setting the same 123412.55, and then for the third variable we are setting 123412.56. Now all three of this value that we assign to the real data type, how this is making a difference, we are trying to see. First of option is like 8, when it is 8 digit less than 5, the 8 digit is less than 5, then what it will do, as you see, this number is like 4 digit, 4, 5, 6 and 7. Now 7th digit is after decimal point, right? So how it will evaluate that 7th digit? So after 7th digit, the 8th digit, if it is greater than 5, right, then only it will make this number rounded. Okay, if it is less than 5, it will not make any change. If it is greater than 5 only, if it is even equal to 5, then also it may not round it to the higher number. Okay, so let us just see in action for all three of these example. You see this, the same values, what we have declared the variable, we have assigned the values in a single with a space. Like this way also you can do, and you can wrap this set statement one by one. Okay, but I have just set them in a single line for the shortest representation. So let us just see in this display how these values are returned. Okay, now first of all we assign what value. This is the original number that was that is what we assigned to this, and after we assign the number, the real data type, how it is stored within the real data type. See, 1234 and here what it has done, it has only stored 7 digit, including the integer part of it, and at the same time the numbers or the digit after the decimal point as well. So all over together total 7 digits, that is what it has done. And here it was 54, right, dot 54. For that reason, if the 4 instead of 4 it was 5, then it could have done kept it as is. But if it was 56 here, then it could have done rounded it from 5 to 6, like what we see here. So see, 54 is made 5 here, like the same way. If it is 55.55, then it will remain same, but if it is .56, then it will round it off to 6. for the 7 digit, but in the output of how it is saved in the real variable is only 7 digits. Okay, whether it is before the digit or after the decimal point, but all of them together is a 7 digit only. Okay, now we will see the second scenario. If we have the digits before decimal point which is equivalent to 7 digit, recently we saw that less than 7 digit before the decimal point. Okay, now here we are seeing like before the decimal point we have equal to 7 digits, and the eighth digit is on the eighth digit is after the decimal point. Okay, so in that case what will happen is, in that case wherever the eighth digit is greater than or equal to 8, then the 7 digit is rounded to the higher number, otherwise keep it as is. Okay, or kept as is. So let's just run again to see that. So first we saw that here that was like a 1 2 3 4, like the 7 digits are there before the decimal point. What it will do, 35 will not do the rounding. Now here what it will do, 55 is there, right? So it has done rounding of the number. Here it was the number like 1 2 3 4 123. Instead of that it has made 124. In the last digit, the 7th digit, it has rounded to 4. Why? Because it is 5, right? So that is how it will do. In the case when the 7 digits are already there before the decimal point, it will round the decimal point after digits after the decimal point, it will round it off up to the whole number. So for that reason it will become rounded number here. So here there is no decimal places that you see decimal point. Instead you see the whole numbers in all three of this case, right? Now the third case, when the digits before the decimal point is greater than 7 digit, then the remaining digits are rounded to a higher number up to the eighth digit, meaning, and when eighth digit is greater than or equal to 5, then 7th digit is rounded to a higher number, otherwise keep it as is. Okay, and finally whichever is the left number, you make that number, the entire number is changed to the exponential value. The final remaining value will become automatically the exponential value. So here in this case what we have assigned the value is like 12341 2233.35. So how many digits? Like 1 2 3 4 1 2 3 3. So 8 digits are there before the decimal point, and after decimal point how many? 2. Now what it will do, if it is the eighth digit, if the eighth digit is less than 5, means here that you see, right, eighth digit is less than 5, then it will not do anything, it will keep the number as is. If it is the eighth digit is 4, what it will do, the ninth digit will round it round, because like here it is 5, right? So 5 will make this 4 as a 5 and rounded to the higher number. And then the 5 will also get rounding, because here 6 is there. So 6 will make this 5 as a 6 again, and then here if it is 6, then this 5 will become 6. So eventually what will be the number? We want to show the 7 digits only in the output. So the 7th digit only will be displayed in the exponential value, and rest of the numbers will become the exponential value. So only 7 digits will be open for you to display. Okay, so let's just see in output, so you will understand much better. Let me just disable this for a sake. Okay. All right. So here what you see, like 448, like the 8 digits before that. What is the remaining is, see, 1 2 3 4 5 6 and 7. 7 digits are there. You see this number, right? The exponential number. So the numbers 1 2 3 4 1 2 3. So it has kept it as is because the 33 is there, right? Here it is 34. So it will become 124. Instead of 123, it has made 124 to this number. Why? Because it is rounding off up to the 8th digit. 8th digit is what? 4th. 4 number here, right? For that reason, it has rounded up to 4. Now, in the last case, like 1 2 3 4 1 2 3 5.56. So how it will be rounded? Again, it will be rounded up to 124, because here it is 123 only, and after that there is a 5 in the 8th digit, or in the 9th digit it is 5, meaning 5 will make the rounding of 3 to 4 again, right? For that reason, it will round it off to that number, and then finally it will be converted into the exponential value, right? So that is how the real data type behaves, right? Likewise, we have the float data type. The same rules, only just the difference in here is the 15 digits. Earlier we were considering only 7 digits in the output, right? Because here if you see, like in every numbers, most of the times only the 7 digits are affected in the output, or 7 digits are displayed in the output, right? Mainly. Likewise, here in this case of float, it will consider only 15 digits, whether it is before the decimal point or it is after the decimal point. Rules remains the same. Only just the second rule changes when the equal to value comes. So let me read this out for you. Digits before decimal point is less than 15 digit and the 16th digit from the entire number. If it is greater than 5, then the 15th digit, meaning like the 15th digit, is rounded to a higher number. Otherwise, keep it as is. Okay. So let us just see. 1 to 9 is like 9, and then again 5, means like 9 plus 5, 14. 14 number, and then 15th is after the decimal point, right? Same way here and same way here as well. But in both the cases, difference is like here the 15th digit is 3, here the 15th digit is 5, and here the 15th digit is 5 and then 6, right? So let us just see it in action. Alright, so how it is changed? It has kept only 15 digits only in the float, right? So that 14 digits before the decimal point and 1 digit after the decimal point. So 4 it has excluded, or it has just discarded, right, from the output. When it is storing it in a float variable, it will just exclude that 4. And then here also the second example. Here it is 34.34 was there, right? Instead of that 55, suppose if it is 55, how it will do? So it will turn from 55 to 6 only, because the 5 will make again the rounding. For that reason, the decimal point will remain same. It will get rounded to a higher number, so it will be 6. So the fifth, the second digit from the decimal after the decimal point will be discarded. Same way here also, like here it is 56. So greater than or equal to or 5, whichever is the case, it will make it rounded to the higher number. That is how it is in the first case. Now the second case. Second case is equal to, means all 15 digits are there before the decimal point. Here it was 14 digits. Now we are considering 15 digits before the decimal point. And after that there are 2 digits, right? So in that case, how it will behave? So again the same kind of conditions, and mostly in that case also, like the greater than or equal to will perform the same role. Meaning if the 15th digit, right, if the 15th digit is 16th digit is greater than or equal to 5, then it will change the 15th digit from the current number to the higher number. Okay, so let us just see in action. Yeah, so here in this case you see like the 34, and it has turned to the rounded number. It has not changed anything in the original number, because all 15 digits were there as is, and after that there was 34 only, so there is no point of rounding, right? Even though if we round this number to the whole, 4 will not turn to the higher number because it is less than 5, right? Here it is greater than 5 or equal to 5, right? So for that reason it will go and change 5 to 6 here in the decimal point. Again 6 will make this 4 to 5, and for that reason the 15th digit, like the 454 that you see here, right? Instead of 454 you will see the 455. You see why it has done? Because it is equal to 5 or greater than or equal to 5, like that, right? So in that case it will behave like that, and then if it is greater than 5 then also it will be the same case. So for that reason also, like 454 is rounded up to 455 now. Okay, so this was the second case. Then the third case. Again, in that case what will happen is the digits before the decimal points are greater than 15 digits. There can be any digits before that, but here I'm just giving it a condition like before the decimal point itself it has more than 15 digits. So in that case how it will do? It's the same rule applies. Means like it will round the whole number up to the 16th number. 16th number will be rounded, and finally if the 16th digit, if it is greater than or equal to 5, then the 15th digit, is rounded to the higher number. Otherwise keep the 15th digit as is, and after everything is rounded to the higher number, then finally change the whole number into the exponential value. That is how it does internally when it assigns the value to the float. Okay, so let's just see the third number. How many digits we have stored before the decimal point, assigned the decimal value to the float variable? Let's see. 1 2 3 4 5 6 7 8 9. So 9 plus 7, 9 plus 7, 16. So 16 digits are there before the decimal point, and after that there are 2 more, right? So here also the same rules as we just discussed. Let's just see in action. Let me just comment this to section for now. Okay, all right, so let's see how it is doing. 16th, right? So the 16th digit, just focus on the 16th digit, where like 7 is the 16th digit here. Okay, and after that what? 34. So 34 there is no scope of rounding because no value greater than 5, right? Or equal to 5 even. Here there is a value equal to 5, so there is a chance of rounding this number to the higher number. So how it will do? 5 will make the previous number as 6. Then the 6th will make the previous number from 7 to 8, and now 8 will change the 6 to 7. So that is what you see here, and then the number is converted into the exponential form. For that reason 1 2 3 4 5 6 7 8 9, then 1 2 3 4 5, and then it was 6 but rounded off to the higher number. Because of that it has become 7, and for that reason the exponential value is like this. Okay, same way the third one, rounding 6 will make it to here also it will make it 6, and then 7 will become 8, and then 8 will again change this 6 value, the previous digit, to 7, and for that reason this is the result. That is how the float values work. Now there are a couple of rules that we need to remember for the float or real data types. What are those rules? So first one is when to avoid using this approximate data types. As we just saw, right, like this rounding off and all. How come it will work as expectedly, right? Because if there is a business need, business may need a certain or an exact value. In the case of reporting, if they need some business reports or some of the financial figures, you need a defined value in the output, right? We cannot always go based on the approximate values, because here there are fixed numbers in the digits. So what they expect is finance, business and operational, any of these businesses should avoid this rounding or equality check. So basically they should avoid these approximate data types. Now in the where clause also, like when you apply these DQL statements, like the data query language statements, which we will be covering afterwards. So what we will be seeing in that is like the where clause. Where clause is used to filter the query result set in the output. So when there are number of records, you want to filter the number of records for a particular column, then that column which contains the approximate values may not give you the appropriate results, because if you use the equality operators like equal to or say like a not equal to, it may never give you the expected result. Instead of using them, try using this greater than and less than, greater than or less than comparison operators. Okay. Now the second rule is when converting the float and data type or float and real data types. Okay, how can we change or convert this float? And because it is an approximate, right? So when if we, even though we for some reason we needed to declare or define that data type as float or real, then for the business sake, if we have to normalize it, right? So how can we cast them, right? How can we frame them, or how can we typecast them rightly? So how can we do that? There are three ways that we can do. Either we can typecast it to the integer value, meaning if this is the number, just for an example, if this is the number, right? If we want to make it an integer, so what will be the value? Only this much part. Only this much part will be covered in the integer value. And it will truncate what? It will truncate 56 from this number, supposedly, if we have used, right? So that is how this typecast will work. So there is a loss of data, but still, if the business agrees, then that is how one of the way we can typecast the floating or say like approximate value to the fixed value, the exact value, right? The second kind of the option is the to typecast them to character type. Now character type, which is like a varchar or something, right? So there is a built-in function for that purpose, str, the string function. Okay. We can use the casting function, the cast function also we can use, that also we will see later in this example only. But what is the difference between them, two of them, is like the str will give you more better result than the cast function does. Okay. So what is the syntax for the str, the string function? The first argument will be that floating expression, or say like a variable, or say like a particular float kind of an field, or say like a column that you will put in this parameter. The second parameter will be length. Length is what? Length is including the signs and digits, decimal point and the white spaces. So the default size of the length is 10 when you want to typecast it, right? So here it can be 10. And decimal, what are the number of how many number of digits that you want? I mean the number of places to the right of the decimal place, decimal point. It must be less than or equal to 16. Greater than or 16 if it is there, then it will be truncated. That is the second data type. Then the third exact data type that you can use to typecast the float or real data type is the decimal and or numeric data type. Now before 2016 there was a precision restriction of 17 digit at max only that you can use for that. But now there is no precision restriction for that after SQL Server 2016 version. Okay. Now let's just see all of these rules and everything in the example. Variables I have defined or declared here based on the typecast that we need to. For that reason, like the real and one variable for float, one for the big int, money, because all of these are an exact data types that we have covered earlier in the previous session. So I'm just giving this example just to typecast the approximate data type to the exact numbers, right? For that reason, we are declaring all these variables. Now, let's just assign this number, the big number, right? Like the almost like the precision part is 38 and the scaling is 14. So how many digits remain? 24, right? So 24 digits are there in the before the decimal point. All of this is like 24 digits before the decimal point and 14 digits after the decimal point, right? So that will be 38 in total. That is the precision. The same way the float value is assigned the same number. Okay. Now both of them, how it will be returning the result is what we will be checking against each of the typecast. The first type, we will be typecasting it to the say like first case we are typecasting it to the big integer, big int variable data type, right? So big int type, if you want to try typecast, big int is of a integer type, right? It is the integer type size. Now if it is integer type of 8 byte size, still the number it can contain, which will be out of this number, what it will be storing in the big int is only the integer part. So when you typecast it, it will say it can typecast up to this much, but the remaining values cannot be typecasted. For that reason, it will throw an exception because the cast function cannot handle it, because it's a it's an overflow basically. Okay, in case if you want to just understand by that, then since the float value is greater than the big int value, big int data type, float value is 8 byte size, whereas and the big int and both, it has the same bytes in size, but the kind of value, or say like the range of values it can store, it is going beyond that limit in the float variable, so that it can not occupy that, and it will throw an arithmetic overflow error. So as to avoid that overflow error, we need to use another kind of function which will be called typecast. Cast will also do that, but it will throw this arithmetic overflow error. But just to avoid this error and set the null value to this variable, we can use the trycast function for that. Okay, so let us just see and run these two variables. Okay, now if we run this, we are definitely sure that it will throw an error for arithmetic overflow. Let's just see. Right, arithmetic overflow error converting expression to data type big int. Okay, it cannot do the same way. Money data type also cannot do the typecasting because it is a huge number to fetch into the money kind of variable. So how can it do? How can it will do this? I mean, it has done the work returning the null value to it, but still the cast function cannot handle this error on its own. So for that reason, just to avoid this kind of an error, it has handled this null, but it cannot handle the exception which has caused or overflow error. It cannot hold it, right? For that reason, we need to change the function from cast to the try cast. Okay, let's just see in action here. Try underscore cast, sorry. Okay, let me just change here as well. Okay, so let's just run here. Okay, now there is no error, right? So this is how you can check and typecast the variables in the respective data type without any errors. Now again we are trying to change it with the character data type. Recently we just tried with the integer using the big int and the money data type. Both of them failed to set the values. Now we will try with the character data type. Character data type is what? It is like a string function that we will be using. And what the value, character data type we use for that is varchar 255 is the size that we have given. 255 varchar will be 255 byte size, right? So we will try to save that value into this variable. So let us just see again. So here we have typecasted it to the varchar data type, right? We can see that value, and we can see that how it has stored the value in the varchar data type, right? What was the number and what was the value that we assigned to variable float. So the variable float has a value like a big 24 digits in before the decimal point. How it has stored all those, let us just see. Up to 9 it is fine, 1 to 9 it is fine. After that 654329, 654329, and then 92, then 34, and then 92, and then 34 did not come, right? So this is how it will store in this in the string function. Okay, so how many digits? Like 9 and 6, 15 and 2, 17. See, 17 digits it has converted, and rest of the digits are converted or rounded to 0. Rest of the digits are converted or rounded up to 0, right? So that is how the string or the string will save the value to the float values, right? Now the third type, decimal or numeric type. How the decimal or numeric type will typecast it? Again, there is a chance of error, right? So to avoid the error, we might have to use the try cast. So let's just run this. Okay, let's just run this, and it will throw the error. Yeah. Okay. Yeah, cast it has worked for the decimal. Yeah, in that case, my bad. So cast it has worked, right? But in case if we want to avoid at any cost, for say like if the number was maybe kind of appropriate to save it in this kind of range, for that reason it could do the typecasting, because the higher range that I may have given, if I had it given like a, let's say maybe less range, then it could have thrown the error for that, right? Because the decimal I have given the 38, 14 as the size. So 24, which is what the exact size, like how we have saved in the original variable. For that reason it has fit that value in that. Okay, now so if we want to put it like, we can put it like try cast in this case. Instead of cast, let's just use it just for a safer side. Maybe in case if the typecast doesn't work for some reason, if there is some exception or error, then also it can handle it. For that that purpose we should always try to use the best practice is try cast can be used. Okay, now all of these variables we just saw, so no need to just separately run this. All of these variables what we just ran, we can see to the data length of them. Okay, now how we can see to them together is let me just disable all this, select separately that we made. Okay, 1 2 3, yeah, so all of them will come together and then the data length will come together. Let's just run everything together. Yeah, so for the real, it has saved it has occupied the data length as 4 byte, right? What is the size or the data length it has occupied for storing this value is 4 byte. Then for the float it has occupied 8 byte. Here there is nothing saved, for that reason no byte size. Now here there is data which is saved in the string, right? So, or say like a varchar. So varchar, how many characters we have saved is 38 digits, but 38 characters is what we have saved. So for each character it has occupied a single byte. For that reason, for 38 characters it has occupied 38 bytes, right? Likewise here in the decimal case it has occupied 17 bytes, right? So everything is as per the declaration, it can save the data. So this is the decimal data type. According to the decimal, it can occupy or it can store up to 17 byte size. For that reason it has written the 7 as a data length to us for the variable, right? So